video again we are just trying to derive the formulas for the integrations of some special forms, and we will be using the method of substitution using trigonometry. So what are these forms? Let me go one by one. Some of them can be solved using trigonometric substitutions, some can be integrated using algebraical manipulation. We will be practicing all of them in one by one different videos. So now here in this video I'll just take some prominent algebraical standard forms, and which are like, first form is how to find integration of a square minus x square dx. Now those who have studied the idea of the rational fractions or the algebra, they know that 1 over a square minus x square can be written as 1 over a minus x times a plus x. This is just the formula a square minus b square is a minus b, a plus b. Now we have to separate. This is a fraction, this is a proper fractions, and this proper fraction can be broken down into the sum or difference of the two proper fractions. How? So first you write 1 over a minus x here and 1 over a plus x here. Now if you see that if you're trying to add them, this one goes there, this one goes there. So if you just add them plus 1, then what you see that on the numerator you will have a plus a minus x. So x cancel, just 2a, which is a constant. So if I write 1 by 2a outside, then this is nothing but this. How? So just for explanations I am just trying to solve that this is a minus x times a plus x, and then here this will be a plus x plus a minus x 1 over 2a. So x cancel, a plus a is 2a, and this 2a cancel with this, so you have just 1 over this. So this is this, and all these three terms are same, but we will focus on this term only. This is just for explanation that how these two things were same. So now at the place of this one we'll write 1 by 2a outside and 1 over a minus x dx plus integration 1 over a plus x dx. So both these terms necessarily were multiplied by 1 over 2a, so 1 over 2a, so I just put them in a bracket, so that after integrations again the whatever result you get, that will be multiplied by 1 over 2a. So it's 1 over 2a. Now what is the integration of 1 over a minus x? That will be the log times this, and differentiation of this one, that is minus 1. So you have minus log a minus x plus integration of this is log mod a plus x. Now you know that log m minus log n can be written as log m over n. So this one is 1 by 2a log mod a plus x over a minus x plus c, and this is the formula. You can say integration of 1 over a square minus x dx is 1 over 2a log a plus x over a minus x. So this is the integration of this particular form. You have to remember this whenever you see this kind of form, integration of 1 over a square minus x square. Another way of remembering this expression is that 1 over the constant square minus variable square with respect to the variable will give you 1 over 2a log mod a plus x over a minus x plus c, this constant of integration. So now I'll take another form. This form, I hope everything is clear. Okay, now I have another form, that is integration of x square minus a square dx, and we will apply the same method, that is 1 over x square minus a square can be written as 1 over x minus a x plus a. So you just write 1 over x minus a here and x plus a here. We are just putting them in such a order so that there is some order. So we have to write this whole expression in such a way that the numerator should remain a constant numbers, like in terms of a. We don't need in terms of x. So if I write here, this one comes here, so I have to write minus here, because x plus a minus x minus a, so x and x will cancel and have 2a. So to compensate that 2a, I write 1 over 2a there. So if you feel like that whether they are same or not, you can just pause the screen and you can verify this is always same as this, and all these three terms are same thing. So instead of integrating this one, I'll go for integration of this one. So I is 1 over 2a integration of 1 over x minus a dx minus integration of 1 over x plus a dx. These are the formulas. So this is, here I have to write a curly bracket, so that, so 1 over 2a log mod x minus a minus 1 over 2a log mod x plus a. Now you know that the plus c is constant of integration. Now you know that x minus a log m minus log n is log m over n. So I don't need to think that this one is here, let it remain here only. Then this is 1 by 2a log mod x minus a over x plus a plus c, and this is integration of 1 over x square minus a square dx. So the integration of 1 over x square minus a square dx is 1 over 2a log mod x minus a over x plus a plus c. So this is the second prominent standard form. Now after this we'll take another form, that is third form. So again we have a form that find the integration of 1 over under root a square minus x square dx. Now when you see a square minus x square, then you have two standard form, that is 1 minus sine square x is cos square x, or the 1 minus cos square x is sine square x. Two other forms are also there, sec square minus 1 is tan square a, and the cosec square minus 1 is cot square. But we will go for the sine square a, because that's so 1 minus sine square, just like constant square minus variable square. So a square minus x square just looks like, can be analogous to 1 minus sine square. So here we have a square minus x square. If you let x is a sine theta, so since, or you can say let x is a sine theta, so this a square minus x square will become a square minus a square sine square theta. Take a square common, this is 1 minus sine square theta, then take a square and this becomes cos square theta. So a square minus x square is nothing but a square cos square theta, and same time since you have substituted a in terms of theta, we need to find differentiation of that also. So x is a sine theta, then dx is a cos theta d theta. So our expression now becomes, at place of dx better write as a cos theta d theta, a cos theta d theta, and inside this square, at the place of a square minus x square, you write a square cos square theta. So this is a square cos square theta. So both terms are same, because this is just the square root of this whole thing. So this becomes a cos theta over a cos theta d theta. So this is 1 d theta, and that is theta. So what is theta now? Theta is just sine inverse x over a. So sine inverse x over a plus c. So integration of this will be sine inverse x over a plus c. Now we have to go for one more standard form, and that is 1 over square root of x square minus a square. So let me clear the screen, and then again I am going to write that standard form. Okay, now this is the standard form, which goes like I is 1 over under root x square minus a square. So you know that in trigonometry that sec square theta minus 1 is tan square theta. So in x, if you take x as a sec theta, then x square minus a square will become a square sec square theta minus a square. That is a square sec square theta minus 1, which is nothing but a square tan square theta, because sec square theta minus 1 is tan square theta. Now for the dx part, here we have dx also. So since x is a sec theta, what is dx? That is a differentiation of sec theta is sec theta tan theta d theta. So our integral will become a sec theta tan theta d theta over square root of a square tan square theta. This gives you a sec theta tan theta upon a tan theta d theta. Now tan theta a cancel. We have just integration of tan theta. Now what is integration of integration of sec theta d theta? Now what is integration of sec theta? That is log mod sec theta plus tan theta plus c. So log, now what is tan theta? Sec theta, because our assumption is in terms of sec theta. So here we write at the place of tan theta, we better write under root sec square theta minus 1 plus c, and this is sec theta. So which is log mod, what is sec theta? That is x over a. So x over a plus under root x square over a square minus 1 plus c, and then you will have log mod x plus under root x square minus a square over a and plus c. So here you get one term, that is log mod x plus under root x square minus a square minus log a, and that log a will be compensated with the c, and that will make a new constant of integration, but we'll write it as c only. I mean to say this log a will be compensated as constant. So our final answer will be log mod x plus under root x square plus a square plus c dash. So now again I am coming back to this, what exactly we are getting here is log mod x plus under root x square minus a square minus log a plus c. Now this thing I am taking as c dash. This is c dash, but here you don't have to write c and c dash. If you go into the higher order, like when you go into the engineering mathematics, then you have to pay attention to this constant and this constant differently. But right now you have just only one term, that is constant. So at the place of c dash you can just write as c, and that is constant of integration. But you can make up your mind that this c is made up of c plus or c minus log a. So this is all about the standard forms right now, and in the very next video we will just go for the other forms which can be manipulated to all these 5-6 standard forms which we have just discussed so far in this video. Thank you very much for watching our videos, and keep practicing with us. Subscribe to our channel, and then have a nice time.